So what we're going to have a look at today is how we can solve one-step equations, and we've already looked at solving equations by inspection just by looking at them, and we've also had a look at what we can do to equations and then still be equivalent. So we're going to take that one step further by looking at solving one-step equations, and to do that we need to know our inverse operations. So we need to know the opposites of some of our operations. What that means is if I ask for the inverse of plus, that's the minus, or add and subtract, and the inverse of multiply is to divide, and vice versa. So the inverse of division is multiplication, and the inverse of subtraction is addition. So we need to know those, and they will help us work through some examples. So let's have a look at some. We had a look at these examples in a previous video. So b plus 8 equals 12, g plus 10 equals 21, and j plus 9 equals 9. Well, we worked out before that if we subtract 8 from both sides, then that will still balance. But how did I know to subtract 8? Well, I've got a plus 8 here, and I'm trying to get the b by itself. So if I take 8 away from this side, for it to still balance, I've got to take 8 away from this side as well. So when I take those 8 away from there, that's gone. And when I take the 8 away from there, I'm still going to have 4 left. Now, normally when I'm doing my equations, I don't normally put my lines through there and do this extra little bit of working, but some people may. I do make sure that I have these negative 8s here, or subtract 8 from both sides, because what that does is it tells me what I'm trying to do. I'm explaining what I'm doing to get my answer. So it is important that I do some sort of working out there. And when I do that, I find that b equals 4. So as I said, I wouldn't normally have those lines through it and that 4 there. Right, so I just would have that bit of working and then my answer. So let's have a look at what I would normally do. The opposite of plus 10. So the inverse of plus 10 is to minus 10. So I'm going to subtract 10 from both sides, and what we'll find is those 10 will disappear there, and it will tell me that g equals 11, which is answers that we got from before. So subtract 10 from both sides, that 10 disappears. 21 minus 10 gives me 11, and I'm just left with my g there. Let's try one more. The opposite or inverse of plus 9 is to subtract 9 from both sides. So 9 take away 9, they disappear and just leave me with the j, and 9 take away 9 on that side is just 0. So I've got my 3 answers. What I can do with an equation is to substitute that back into here and see if it works. So 4 plus 8, that equals 12. Yep, that's what I want to have, and I know that's right. I said that g was 11. 11 plus 10, that's 21. That's what I want. So yes, I know that's right. J equals 0. Substitute it back up here. 0 plus 9 is 9. Yes, that's what I want. So I know my 3 answers are correct there. Also, from a previous video, we had these examples here. The inverse of negative 4, or take away 4, is to plus 4. So add 4 to both sides. So negative 4 plus 4 is 0. They cancel out. And I'm just left with my w. And 2 plus 4 equals 6. So w equals 6. And again, I can test it. 6 take away 4 is 2. Yes, that's what I want, so I know that's right. Our next one. Our opposite of take away 7 is to plus 7 to both sides. They cancel out because negative 7 plus 7 is nothing. So it just leaves me with the z on that side. And on this side, 1 plus 7 equals 8. And again, test it. 8 minus 7 is 1. Yes, that's what I want, so I know that's right. And our last one here, opposite of take away 10 is to plus 10 on both sides. So they cancel out there, and 20 plus 10 equals 30, so r equals 30. So our shortcuts that we might have seen from our inspection, solving by inspection, you may have worked out that if we just do the opposite, so 2 plus 4, 1 plus 7, 20 plus 10, and that will give us the answers there. So let's have a look at some more. Our multiplication ones. So 2 lots of A equals 10. Again, you might be able to see that from inspection, but the opposite of multiplying by 2 is dividing by 2. So when I do 2 divided by 2, that's 1. So that leaves me with 1 lot of A, which is just A. And 10 divided by 2 is 5. So I get A is 5. And again, we can check it. 2 lots of 5 is 10. That's what I want. Yes, so I know it's right. So my next two examples look a little bit different from what we've seen in the previous video. What I haven't got here is the multiplication sign in between, so 5 lots of H. But with algebra, we can write things in shorter ways. So 5H with no sign in between means 5 lots of H, or 5 times H. So our inverse operation of multiplying is to divide both sides by 5. So our 5's will disappear here, they cancel out, and it'll leave me with just H, and 35 divided by 5 is 7, so my H value is 7. So again, I can check that by putting it back in here. Just be careful though, that's not 57 now when I replace the H with a 7. That's 5 lots of 7, and 5 lots of 7 is 35, which is what I want, so I know that's right. And the same with this one. No sign in between, so it means multiplication. 3 lots of D equals 36. The inverse of multiplying by 3 is to divide both sides by 3. The 3's here will cancel and just leave me with the 1D, which is just D. And 36 divided by 3 is 12. So we get D equals 12. So again, replace it back up here to check. 3 lots of 12 is 36. Yes, that's what I want, so I know that the answers there correct. So let's now have a look at some division questions. And what you will notice is that, yes, I've got U divided by 5 equals 4 as a previous one. And I've actually changed the way that these two division questions look. So S/2 is the same as S divided by 2. More likely it will be written in a form like this, P over 9, so as a fraction. That vinculum there, the line in the fraction, same with here, means divided by. So it's not going to be anything different, it just looks different. So let's go and solve these. The inverse of divided by 5 is to multiply by 5, so we've got to do it to both sides for it still to balance. And these will cancel out and just leave me with the U, and 4 times 5 is 20. So we get the U value is 20. Again, we can check it by doing 20, replacing it here. 20 divided by 5 is 4. That's what we want, so I know that's right. So our next one, S divided by 2. The opposite of dividing by 2 is to multiply both sides by 2. Remember, we've got to do the same to both sides for it still to balance. These will cancel and just leave me with the S, and 7 times 2 is 14. So the S value is 14. Again, check it. 14 divided by 2, that's 7. That's what we want, so yes, that works. And our last division question here, dividing by 9. So to have P by itself, I'm going to do the inverse. So I'm going to multiply both sides by 9. And when we do that, they disappear, and it just leaves me with the P. And 6 lots of 9 is 54. So we just had a look at how we can solve them. Let's go back to our harder ones that I've finished off, our one-step equations, our inspection equations. If we know these shortcuts now, we should be able to solve these. So let's look at our inverse operations. The inverse of add 27 is to subtract 27 from both sides. Do the same to both sides. They eliminate. Just leaves me with the A. And 182 minus 27 will give us 155. So our A value is 155 because we've eliminated 27 or subtracted 27 from both sides, and just leaves me with the A value by itself, which is what we're trying to do. So our next one, let's do the opposite or the inverse of subtract 81 to get rid of that. We want the B by itself. So let's add 81 to both sides. They will cancel out. just leave me with the b value, because minus 81 plus 81 is nothing. Just leaves me with the b there. And 54 plus 81 will give us 135. So our b value is 135. Again, we can check it, replace it here, 135 minus 81, and check that we get 54 as an answer. And if we do, then we know that's correct. Our multiplication question, we have there 3 lots of c equals 102. Our inverse of multiplying by 3 is dividing by 3, so let's do the same to both sides. And that will leave me with just the c on this side, and 102 divided by 3 gives me 34. So again, check it, 3 lots of 34, check that we get 102, and if we do so, we know that's right. And our last one here, we're dividing by 15, so d divided by 15. Our inverse is to times both sides by 15. When we do so, our denominator disappears. That's our little trick. That's our advantage of doing that. Leaves me with just the d, and 17 times 15 gives us our 255. So, when we looked at these in our inspection video, solving equations by inspection, they were a little bit more complicated to do, but now that we know inverse operations, or doing the opposite, it's much easier to actually work out. So what I'm going to do now is finish off with just 4 harder equations, but we're going to practice our inverse operations. So v plus 8.3 equals 25.1. So at the moment we've just been working with whole numbers, positive integers, and we're now going to have a look at some decimals and fractions examples and see what happens there. So the inverse of plus 8.3 is to subtract 8.3 from both sides, and that will tell me that v equals 16.8. So 16.8 plus 8.3 is 25.1. So not so easy to be able to see that answer by inspection. So if we know our inverse operations, it's so much easier to work out. Another one, y minus 3/4 equals a half. So the opposite of subtracting 3/4 is to add 3/4 to both sides, and we get y equals 1 1/4. So they will cancel out on this side, and a half plus 3/4 is 1 1/4. Let's have a look at another one. 12 times something equals 4, so 12m equals 4. So the opposite of multiplying by 12 is to divide by 12, and when we do that, we find that 4 divided by 12 is a third. So these will cancel out and just leave me with the m, and we get 4 over 12, which simplifies to 1/3. And one final example, d divided by 7 equals -2. So the opposite of divide by 7 is to multiply both sides by 7, so it still balances. The denominator will cancel here and just leave me with the d as the numerator, and -2 times 7 is -14. Again, we can check it. -14 divided by 7. How many 7s in 14? That's 2. How many 7s in -14? That's -2. So we can check them to make sure that we're right. So I hope you found this this video useful, and that you now find that solving equations, especially one-step equations, is so much easier, even when we have more complicated ones. So thanks for watching.